Alright, we're going to start reviewing for your Conceptual Unit 2 test. The first question on your Math Excel homework is going to be similar to mine, and it wants to know what the conjugate of 9 plus the square root of 5 is. Those are our choices, and if you remember from the definition of conjugate, if you have 9 plus the square root of 5, to get its conjugate, you keep the 9, you keep the square root of 5, and you simply change the sign that's in between them. So since his was positive, the conjugate would be negative. So the correct choice is 9 minus the square root of 5. Next, we rationalize the denominator of that fraction by multiplying the numerator and denominator by the conjugate of the denominator, always. So in my case, the conjugate of the square root of 17 minus the square root of 7 would be the square root of 17 plus the square root of 7. In the expression, the cube root of 64, the number 3 is called the blank and the number 64 is called the blank. If you remember from our days of definition of radicals, the index was always in here and the radicand was underneath. So in my example over here, 3 would be the index and 64 would be the radicand. If n is even, then the nth root of a to the n. This has to do with the absolute value bars. If I take the nth root of a to the n, you know that the n's will cancel out, whether n is even or odd. But if n is even, then when they cancel out, the a gets out inside bars. If n is odd, and the n's cancel, then a gets out without bars. So if n is even, the nth root of a to the n's cancel, a comes out in bars. If n is odd, the n's cancel, a comes out without bars. Fill in the blank so that the resulting statement is true. If you remember from our definition of powers, if we have x to the m over n, we can write that as a radical if we put this inside and we put this on top and we put this in the index. So we simply transfer everything over. X goes under, the m goes up here, and the n goes in the hole. So a to the 1 over n would be n in the hole, a underneath, exponent of 1. Yay. Okay, use the product rule to simplify the following expression. Sorry, my calculator just got plugged in. Alright, you could try to break these down first, or you can multiply first and then break it down and simplify. I usually don't bother doing them individually and then putting them together. I generally like to multiply them together. So a square root times a square root is a square root. 6 times 24 is 144. X squared times x to the first is x cubed. So now if we break this down, if I break down 144, by 2 is 72, by 2 is 36, by 2 is 18, by 2 is 9, by 3 is 3. Since my index is a 2, I'm looking for sets of 2 to make a perfect square. There's 2 2's, that makes a perfect square. There's 2 2's, that makes a perfect square. There's 2 3's, that makes a perfect 3. Okay, or you just knew that the square root of 144 was 12. But when we do our variables, we have x to the cube, square root of x to the cube, third. So when you do this, you take the exponent, 3, divided by the index, 2. 3 divided by 2 goes 1 whole time. Take 2 away, leaves 1 left over. So one copy of x gets out. One copy of x will make a perfect square. And one copy of x has to go back in. So now, if we put all our stuff together, okay, I have a 2 out, a 2 out, a 3 out, an x out. Those are my perfect squares. And on the inside, I have a copy of x left over. So my final answer is 2 times 2 is 4, times 3 is 12, times x is 12x, square roots of x. Okay. 12x. And then you gotta click the little button down here. Oh, I didn't mean to click that one. How do you go back? Well, I could just type it, I guess. No. Pardon me. Sorry. Now I know how you guys feel. Okay. 12x, square roots of x. Good job. Alright. Same the way we just did the division, the multiplication, we can do the division. I don't want to look at the top and the bottom separately, so I'm going to make it one radical with 72x to the 4th divided by 3x. So if I take 72 divided by 3, that's going to give me the square root of 24. And divide my x's, x to the 4th divided by x to the 1st is going to be x to the 3rd. And now we're right back to where we started. We're going to break that down. So if I break down 24, by 2 is 12, by 2 is 6, by 2 is 3. Because my index is a 2, I need 2 copies of something to make a perfect square. I have 2 2's, that makes a perfect square. There's not 2 more 2's, so he has to go back. There's not 2 3's, so he has to go back. If I break down my x cubed, my square root of x cubed, I take 3 divided by 2, goes 1 whole time. 1 times 2 is 2. Take away 2 leaves 1. So one copy is going to make a perfect square, and one copy is going to have to go back in. Okay, so if I got a 2 out, I got a copy of x out. Those are my perfect squares. Okay, my non-perfects, I got a 2, a 3, and an x. So if I put everything back together, outside is yellow, 2 times x is 2x. Inside is green, 2 times 3 is 6, times x is 6x. And we'll see if Henny's on a roll tonight. 2x, square roots, whoops. Oh, pardon me, guys. Oh, poop. Hold on. I'm not good at technology. Okay. 2x square roots of 6x. Yay. Okay. Sorry, it's taking a while. Alright, rationalize the denominator. When we rationalize the denominator, we cannot leave radicals underneath. We just talked about it at the beginning. To rationalize the denominator, you multiply the top and the bottom by the conjugate of the bottom. The bottom is 3 plus the square root of 23, so my conjugate is going to be 3 minus the square root of 23. If I do it to the bottom, I have to do it to the top. And I'm ready to simplify. On top, I have 11 times 3 would be 33. 11 times the negative square root of 23 would be negative 11 square roots of 23. And I can't simplify. I can't break down 23. It's prime. Okay, so the top is done. On bottom, I'm going to have 3 times 3 is 9. 3 times the negative square root of 23 is negative 3 square roots of 23. Positive square root of 23 times 3 is a positive 3 times the square root of 23. A positive square root of 23 times the negative square root of 23 is going to be a negative square root of 23 squared. If I clean this up and simplify it all out, the negative 3 square roots of 23 cancels the positive 3 square roots of 23. And this, the square cancels out, so that becomes minus 23. This drops down. 9 minus 23 is negative 14. So my bottom becomes negative 14. Now, the only thing I would say is that most teachers or mathematicians or I don't know, whoever, somebody decided that we shouldn't have the bottom negative. So if I multiply every term by a negative, times negative 1, times negative 1, times to bottom and top, I'm legal. That makes it negative 33 plus 11 square roots of 23 all over positive 14. So I need my fraction. On top, I'm going to have negative 33 plus 11 square roots of 23. On bottom, I'm going to have 14. Oh, darn it. All over. How do I get to the bottom? All over 14. Yay. Alright. When you multiply powers, okay, we have 5x to the 1/3 times 3x to the 1/6. When you multiply powers, the rule says you multiply the number, the base, or the coefficients. 5 times 3 is 15. You keep your x, because when you multiply, you add exponents. So I would have 1/3 plus 1/6. Now all I have to do over here to the side is figure out what 1/3 plus 1/6 is. Remember that handy dandy trick I taught you. If you need a common denominator, it might not be the smallest, but if you just rewrite it, and this works every time, again, you'll have to reduce later, but we can handle that better. All you do is you multiply the first fraction by the bottom of the second. So 1 times 6 becomes 6, 3 times 6 is 18. And to get the second fraction, you multiply everything in the second fraction by the bottom of the first. So 1 times 3 is 3, 6 times 3 is 18. Now they match. Keep the bottom, and 6 plus 3 is 9, which that reduces down to 1/2. So this gets replaced with 1/2. Okay? So I'm going to have 15x. I gotta hit this little caret thing, and then the fraction thing, and put 1 over 2. Yay. Alright, is the algebraic expression a polynomial? If it is, write fill in the answer box with your choice. 8x cubed plus 4x to the 4th. 8x cubed plus 4x to the 4th minus 3. Okay? The no-nos, the only way you can say something is not a polynomial is if, or that you can say, yeah, it's not, is if it is not a polynomial if you have negative exponents, like x to the negative 3rd. You have fractional exponents, x to the 1/2, or you have radical or variables under the radical, or you have variables in the denominator. Okay? So, if none of these things are there, then I can say yes, it's a polynomial. Well, there's no negative exponents, there's no fractional exponents, there's no radicals with letters underneath, and there's no variables and denominators. So, yes, it is a polynomial. Now, the second part of it is to put it in standard form. Standard form means that you list the terms in order from highest degree to lowest. So this term has degree 3, this term has degree 4, this term has degree none. Okay? So if I put those in order from highest to lowest, I get 4x to the 4th plus 8x cubed minus 3. And so that is what I will need to type. So we've got 4x caret 4 arrow over plus 8x cubed. Another one of those. And minus 3. Sorry this is taking so long. It's just very hard to run a keyboard, a mouse, a pen, a tablet, and it's a split screen. Whew. Okay, so 5x plus 4 over x. Is it a polynomial? Well, do we have variables in the denominator? Yes. That means that the expression is not a polynomial. Alright, perform the indicated operations. Write the resulting polynomial in standard form and indicate its degree. When you have, they're saying the first polynomial is 5x squared minus 7x minus 1, plus the second polynomial, 3x squared minus 5x plus 8, minus the third polynomial, x squared minus 5x minus 2. Okay? They're telling you to add and subtract these polynomials. But really, all you need to do is just follow order of operations. Alright? If you look at, there's nothing touching this wall. No positive, no negative, no nothing, which means that's really a positive. But if you distribute a positive, nothing changes. So I'm going to still have 5x squared minus 7x minus 1. On the second wall, okay, we have a positive touching it. So if you distribute a positive, I get positive 3x squared, negative 5x, positive 8. Nothing changes. On the third set of parentheses, you have this negative. So if I distribute the negative, I get negative x squared, positive 5x, positive 2. Okay, which in PEMDAS order, we've gotten rid of the parentheses. Okay, so next, you're going to combine like terms. Alright, I have an x squared, an x squared, and an x squared. So 5 plus 3 minus 1 is 8 minus 1 is 7x squared. Yes? Okay, wrong color, sorry. Oh, look at that. Okay, we have a first degree x, a first degree x, and a first degree x. So I have negative 7 minus 5 plus 5, which gives me a negative 7x. Okay, and then finally I have my constants. I have a negative 1, a positive 8, and a positive 2. So type negative 1 plus 8 plus 2, and you get 9. Positive 9. So my final answer is 7x squared minus 7x plus 9. Yeah? 7x squared minus 7x plus 9. Okay, the degree of the polynomial is the degree of it's the highest degree of every term. This has degree 2, this has degree 1, this has degree none. So the degree of the polynomial is 2. Alright, we are multiplying polynomials. It's just distributive property. You have 2x plus 3 times x squared minus 8x plus 7. The story I told was this is like the math house. These guys are severely, severely addicted to math. Okay? And this is the math that they want. They want that, and they even want that. And they are dying to get their math. Alright, so the first thing I'm going to do is distribute the 2x. So 2x times x squared would be 2x cubed. 2x times negative 8x would be negative 16x squared. 2x times positive 7 would be positive 14x. Okay, he's done. So the next one to go is positive 3 times x squared would be positive 3x squared. Positive 3 times negative 8x is negative 24x. Positive 3 times positive 7 is positive 21. Okay, which now parentheses are gone. So we're right back to combining like terms. There is no other third degree term, so it drops down. Okay, next I see a second degree x and another second degree x. So negative 16 plus 3 would be negative 13x squared. Okay, next I see a first degree x and a first degree x. 14 minus 24 would be negative 10x. And I don't see any other constant, so it drops. And that is going to be my final answer. Hope. 2x cubed minus 13x squared minus 10x, 10x plus 21. Yay. Alright, it says choose the technique A through G for factoring the polynomial. Okay, remember what you're looking for. Count the terms. That's flow chart that was in your notes. 16x squared minus 25. When there's two terms, the first thing you want to check for one of your specials. Is it difference of squares? Is it sum of cubes? Or difference of cubes? Okay? There's two terms, and sure enough, those are perfect squares. The square root of 16x squared is 4x. The square root of 25 is 5. So this would factor into bino, plus, and mino. So the best term is to use difference of squares, which I'm looking for. Factoring the difference of two squares. Sorry, my eyes are old and tired. Okay, and what about this one? Well, again, I stated that there's only two terms. They're not perfect squares because that is the 3. So I'm thinking perfect cubes. So if I check it out and I try and take the cube root, that would be 5x. And if I take the cube root of 1, it would be 1. They are perfect cubes, so we are going to be doing the difference of cubes. That would be the best technique, which is bino, trino, minus, plus, plus. Yes. Alright, which technique should be used to factor this one? The first thing I notice is there are 4 terms. Anytime there is 4 terms, we are at Noah's Ark, 2 by 2. That was called factor by grouping. Alright, which technique should be used to factor this polynomial? This is just, remember when it goes second degree, first degree, constant, that's just a general trinomial. Alright? So difference of two squares, no. Sum of two cubes, no. Trial and error is what they call it. You know, mine is the AC song, but trial and error. Okay. Alright, so again, choose the technique for factoring the polynomial. There's only two terms, 5x squared plus 10x, but it's none of my specials. It's not difference of two squares. It's not difference of two cubes. It's not sum of two cubes. When they have nothing in they're not one of the specials, alright, then the only thing I see is that I can GCF times what's left. I can pull out a 5x. That was called the factoring out the GCF. Okay? Alright, it says factor out the greatest common factor. I have x times x plus 11 minus 14 times x plus 11. When you have these weird looking things where you already have parentheses, sorry, I had to cough. What you look for here is what matches. You see my minus sign in the middle? I want to notice what matches on both sides of that yellow. Well, doesn't both sides have an x plus 11 in common? Sorry, I had to have a coughing fit and I didn't think you wanted to hear it. So, now that's why they're still calling this the greatest common factor technique, because what they have in common on both sides is that x plus 11. So to get what's left, you would factor out the x plus 11 from both sides. Cancels, cancels, and what's left is an x and a minus 14. Done. Okay. So now we have to type that in. Wonderful. So we have, I guess I did on the keyboard. Parentheses, x plus 11, parentheses, x minus 14. I'm so sorry. Alright, factor by grouping. Again, I know this is grouping because there is 4 terms. Anytime there's 4 terms, you're ready to hit Noah's Ark. 2 by 2, GCF, GCF, GCF again. Woo! So I'm looking for what these two have in common over here. Okay, a 3 and a 5 have nothing but 1 in common, but they do have 2 copies of x in common. So I GCF by x squared, divide to get what's left. If I divide 3x cubed by x squared, I end up with 3x. Negative 5x squared divided by x squared gives me negative 5. On the other side, the only thing they have, the biggest number that'll go into them is a 3. And remember, we always pick the sign on this side of the wall, so my GCF is a negative 3. Negative 9x divided by negative 3 is positive 3x. Positive 15 divided by negative 3 is negative 5. And then we're at GCF again. Well, guess what you're looking for? Okay, look familiar? Do you see the wall? What matches on both sides of the wall? 3x minus 5. There's my GCF again. Divide by 3x minus 5. Divide by 3x minus 5. Cancels, cancels, and I'm left with x squared minus 3. Woo! Okay. So, parentheses, 3x minus 5, closing, opening, x squared minus 3 yay. Alright, factor the given polynomial. When a is 1, guys, I have x squared minus 13x plus 40. When a is 1, you don't have to do the whole a times c sum. All you have to do is it's always going to be two binomials, x and x, because we need to make x squared, yes? And then I need factors of 40 that make 13. So to the side, write all the factors of 40. 1 and 40 won't make 13. If you subtract, you get 39. Add is 41. 2 and 20 will not make 13. 3 doesn't go into 40 evenly. 4 goes into 40 10 times. Again, add is 14, subtract is 6. It's not what I want. 5 goes into 40 8 times. If I add, I get 13. So that is my pair. So you literally put 5 in one, 8 in the other, and then you decide on your signs. My C is positive, right? Because A is 1, B is negative 13, C is positive 40. Correct? If C is positive, then both copy whatever is in the middle. If C is negative, only bully gets to copy it. And the other one has the opposite. But in my situation, C is positive, so both get to copy this sign, which makes them both minus. So my factors are x minus 5 and x minus 8. X minus, yes. Okay. 6 more, guys. Alright, we've got to factor another general trinomial, but this time A is not 1. In this case, A is 5, B is negative 4, C is negative 28. So here goes the A times C sum. First step, A times C. So 5 times 28. I'm not going to worry about signs. Okay, I'm just going to take 5 times 28, and I get 140. And I'm going to write all the factors of 140. And you just type in your calculator. 140 divided by 1, you get 140. 140 divided by 2, you get 70. 140 divided by 3, you get a decimal. 140 divided by 4, you get a decimal. 140 divided by 5, oh no you don't, I'm sorry. 140 divided by 4 is 35. 140 divided by 5 is 28. And keep in mind, I'm trying to make what in the middle? I'm trying to make a 4. Okay, these are all too far apart. 140 divided by 6, decimal. 140 divided by 7 is 20. It's 27 or 13. We're getting closer. 140 divided by 8 is a decimal. 140 divided by 9 is a decimal. 140 divided by 10 is 14. I can make 4 out of that. So that is my pair, 10 and 14. Okay? So the next step is, and I need to erase some things. I'm going to erase this so that, oops, thought I picked erase here. Okay, so we found our factors, okay? So then it says, so that's my 8 times C. The next step is rewrite B. So literally, my original equation was 5a squared minus 4a minus 28. The song says rewrite B. And I already figured out how. Okay, I already figured out how. It's going to be a 10A and a 14A. Has to be. I found the pair that'll work. Guaranteed. It always works. All you have to do is figure out the signs. Well, that's actually pretty simple. Same rule follows. Okay, if C is positive, then they both get to copy B. If C is negative, only the bully does. So since my C is negative, bully 14 gets to take the sign of B, which is the negative, which means 10 has to take the opposite and be positive. Okay? Everything else, the 5A squared and the minus 28 drops. So we've done A times C, rewrite B. Now count the terms. How many terms do you see? 1, 2, 3, 4. We've already learned this. You're at grouping. 2 by 2, GCF, GCF, GCF again. Woo! So on the left-hand side, what's the biggest number that goes into them both? 5 and 1 copy of A. So my GCF is 5A. Divide and you get an 8 left. 5A squared divided by 5A is a to the first. 10A divided by 5A is positive 2. Sorry, another coughing fit. Okay. Go to the other side. And we can factor out they have a 14 in common. And you always take this guy's sign. So you're going to take the negative. And I have negative 14A divided by negative 14, which leaves me A. I'm sorry, I got to put negative 14 in there. So my GCF is negative 14. Divide and I get A. And I get negative 28 divided by negative 14 is going to be positive 2. GCF again, you're going to look for what's in common on both sides of the wall, which is an A plus 2. If you divide by both sides by A plus 2, cancels, you're going to have 5A minus 14. And I'm done. Woo! So I have parentheses A plus 2 and 5A minus 14. Making sure I'm typing it right. Okay, count the terms. When there's only 2 terms, chances are it's one of the specials. And I see 2's in the air. That makes me think difference of squares. So check it out. What's the square root of 25x squared? 5x. What's the square root of 81y squared? 9y. If they're perfect, 2 things have to happen. These have to be perfect, meaning no decimals, and this has to be a minus. If all things check, then you're ready to sing the difference of square songs, which is bino, plus and mino. And all you have to do is fill in the terms, which you already found. So it's going to be 5x plus 9y and 5x minus 9y. 5x plus 9y and 5x minus 9y. Make sure I'm typing it right. Okay. Be careful, sometimes you have repetitive factoring. So if I take 16x to the 4th minus 81, there's 2 terms, so I'm thinking one of my specials. Since this is a 4, which is a multiple of 2, I'm going to assume squares instead of cubes. So if I check it on the side, the square root of 16x to the 4th would be 4x squared. The square root of 81 would be 9. They're perfect. Remember, make your checklist. perfect, perfect, and a minus, we're ready to factor. And our difference of square song is bino, bino, plus n, mino. And I get 4x squared plus 9 and 4x squared minus 9. Oops, sorry. Boy. And if there was my terms, right? Okay, now if I type that in, I would get it wrong. And that's because I'm not quite done yet. Remember, it's like saying that 12 factors into 6 times 2, and your teacher counted it wrong because you can factor 6 into 2 times 3. You can make it more, get it into its prime factors and not just any old factors. Same thing with polynomials. There's nothing I can do with this polynomial. That would be the sum of squares, which we haven't learned how to do yet. So this one just has to drop down. 4x squared plus 9. The other one, on the other hand, is the difference of squares. That can be factored further. Bino, bino, plus n, mino. The square root of 4x squared is 2x, and the square root of 9 is 3. So my terms are 2x plus 3 and 2x minus 3. All right. Sorry, this is a pain. 4x squared plus 9. Sorry. 2x plus 3 and 2x minus 3. Awesome. Alright, sum of cubes. So I have x cubed minus 8. You're going to check to see that they're perfect cubes. The cube root of x cubed is x. The cube root of 8 is 2. And if you're not sure why, factor it down. By 2 is 4. By 2 is 2. But now because my index is a 3, it takes 3 of something, 3 copies of the same thing to make not a perfect square, but we're going to make a perfect cube. So I have 3 2's, which makes a perfect cube. I can't draw a cube. I could, but it's not going to look very pretty. Okay, so that made a perfect cube. And none was left in. So what got out is a 2. All right, so they are perfect cubes. Your cube song says bino, trino, minus, plus, plus. Your terms that go to the bino are the 2 from there. So x and 2 go to the bino. Now the story I told was this is a bino party and a trino party. At the bino party, it's just algebra 1 stuff. Kind of, you guys are big kid kids. You got better things to do than algebra 1. So you want to go to the trino party, because at the trino party, they're doing algebra 2, which is cooler than algebra 1. Okay? So you're going to head over to the trino. And so X says, well, I was first in the bino party, I'm going to be first at the trino party. So he heads over, but the bouncer stops him and says, you ain't getting in until you square yourself. So X says, poof, I squared myself, now I'm X squared. All he had to do was multiply by himself. And 2 says, well, that's cool, I'm going to do the 2. So he goes over and he says, I'm going to be last in the trino house because I was last in the bino house. And the bouncer says, you can't come in until you square yourself. And 2 says, cool, poof, I squared myself, now I'm 4. And they let him in. Now, the middle term doesn't really follow my story, but to get the middle term, it always, always, always works. You multiply these 2 together. So x, no sign, because we already figured out the sign with the song. X times 2 is 2x. And I am done. So I have x minus 2 times x squared plus 2x plus 4. Close my parentheses. Yay. What just happened? Oh, very close. Sorry, technical difficulties. My husband and my son are probably both on the internet. Let me hit pause. And we're back. Alright, the next question finally popped up. And we have 64x cubed minus 1. I'm thinking it's only 2 terms, so it's got to be one of my specials. And it looks like cubes to me instead of squares, so if I test it, the cube root of 64x cubed is 4x. Because if I break 64 down, by 2 is 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. So sorry, but now my index tells me that I need 3 of the same thing to make a perfect cube. So there's a perfect cube, and there's a perfect cube. Yes? Okay, and there's none left in. The x cubed, when you take the cube root of x cubed, they cancel and you get x. So on the outies, I have a 2, and an x, which makes 4x. If you check the last term, the cube root of 1 is 1. That's perfect. So we have difference of cubes. The song for difference of cubes goes bino, trino, minus, plus, plus. I'm so sorry. Okay. So, to get your terms, you just go back to your roots, 4x and 1. Those are the ones going to the bino. 4x tries to go to the trino. The bouncer says, square yourself. Now that means 4x times 4x, which would be 16x squared. Okay, 1 goes to the trino, square yourself, which is still 1, and multiply these two together. 4x times 1 is 4x in the middle. So my answer is 4x minus 1 times 16x squared plus 1. All right. Okay, here we have to basically rationalize the denominator, because you just like you can't have radicals in the denominator, you can't have i's in the denominator. So what you do is you multiply the bottom and the top by the conjugate of the bottom, which would be 1 minus I. On top, if I distribute the 8i times 1 would be 8i. 8i times negative I would be negative 8i squared. Okay, and remember, anytime you get an I squared, that turns into a real negative 1. So now if I keep simplifying up top, distribute, I get 8i plus 8. And in proper form, though, you don't write imaginaries or before reals. So my numerator is going to be 8 plus 8i. On bottom, if I distribute, 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is positive I. Positive I times negative I is negative I squared. And if you notice, a positive I and a negative I will cancel. So now I have 1 minus the I squared, which gets replaced with a negative 1. Distribute, and I get 1 plus 1, which gives me 2. Now, that's not wrong, but because everything can be reduced by a factor of 2, I can reduce and get 4 plus 4i. Oh, I'm sorry, by a factor of 4. Oh my gosh, you guys, I'm so sorry. I just can't quit coughing, but I gotta finish this for you because it's tomorrow. I'm sorry, so the bottom is 2. So, yes, I can reduce by a factor of 2, I meant. So divide by 2, divide by 2, divide by 2, you get 4 plus 4i all over 1, which is just 4 plus 4i. Okay. Same thing here, just a tad bit more complicated. All right. I have 1 plus 8i over 2 plus 5i. And I can't leave i's in the denominator. So I have to rationalize, which means I'm going to multiply the bottom and the top by the conjugate of the bottom, which would be 2 minus 5i. Okay, on top, 1 plus 2 is 2. Not 1 plus 2, 1 times 2. 1 times negative 5i is negative 5i. Positive 8i times 2 is positive 16i. Positive 8i times negative 5i is negative 40i squared. Okay. We're going to combine like terms and replace the I squared. So I have 2 minus 5i plus 16i minus 40 times negative 1. Do this, guys. We're almost through one problem. Last problem. Excuse me. All right, so now I'm going to combine like terms. A negative 5i and a positive 16i makes an 11i. And I have a positive. And the 2 and distribute here, I get positive 40. Combine like terms, and I have 42 plus 11i on top. On bottom, I'm going to distribute. 2 times 2 is 4. 2 times negative 5i is negative 10i. Positive 5i times 2 is positive 10i. Positive 5i times negative 5i is negative 25i squared. This is going to be the worst recording ever. Good grief. Okay. Negative 10i, positive 10i are going to cancel out. And this I squared is going to turn into a real negative 1. So distribute, and you get 4 plus 25, which is 29 on the bottom. The only way you wouldn't be done right now is if the 3 outside numbers, outside numbers, could be simplified, which they can't. So I'm done. I apologize, that was probably right in your ears. Okay, on top I have 42 plus 11i, and on bottom I have 29. Uh-oh. Although your answer is equal to the correct answer, it is not in the correct form. Be sure to read any instructions given in the problem. I'm going to hit pause and think about that and cough my head off. Hold on. Sorry. I know what they want. They're so goofy. Remember, if you remembered on Math Excel, it was, they split it. So they did 42 over 29 plus 11 over 29i. That's what they're looking for. Try and get in this box. Alright, so let's try this again. We need a fraction. 42 over 29 plus another fraction, 11 over 29 to the side, I. Hallelujah. Sorry if that offended anybody. Alright, guys. Please study, 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 study. And good luck on your test tomorrow. Have a good night.